Hello, my name is Steve Bowler, and welcome to the Juniper Border Gateway Protocol, BGP Lab number 8. In this lab, we're going to take a look at multipath and load balancing. We're going to show you how to configure multipath and also per packet load balancing. We're going to perform this configuration on router 1, and then we're going to do some show commands for verification and some tracing to verify that we have multipath and load balancing configured correctly. So the first thing I want to do before we get into the configuration is I want to start off by explaining our current network topology. We have 4 routers, router 1, 2, 3, and 4. Router 1 is in Autonomous System 100. Router 2, 3, and 4 are all in Autonomous System 200. We are using logical systems in this video. If you're not familiar with logical systems, I have a couple of videos that explain logical systems in detail, so I would encourage that you watch those logical system videos to familiarize yourself with the concept. Very high level overview. Logical systems allow us to, inside of one physical Juniper router, we're able to have virtual routers and connect them together. And so that's what we're using in this lab and in a lot of our videos for training purposes to show you. In this case, we're going to be doing some BGP training. So you can also run other routing protocols as well. So logical systems are very cool, especially in a training environment like we're doing. The logical systems are connected together via logical tunnels, and all of the logical tunnels equal LT120.XX. For instance, on router 3, the connection to router 1, we're just showing LT.31, but this is actually interface LT-120.31. So I'm going to go ahead and explain the networks that we have. We have between router 1 and 2 the 12 network, between router 1 and 3 the 13 network, between router 2 and 4 is the 24 network, and between router 3 and router 4 is the 34 network. The IP addressing is as follows. Router 2, all of its interfaces are configured with the .2. Router 1 is the .1, router 3s are the .3, and router 4 is the .4. On router 1 we have an interface loopback 0.1 with the 1 network and the 11 network, both of those /24s. We're going to be advertising this interface into BGP and sending it to Autonomous System 200. We're going to use that for some verification after we get multipath and load balancing set up. On router 4 we have an interface loopback 0.4. We have a lot of networks off of it. We have the 4 network, the 44 network, both of those /24s. We have the 200, 0.0.0, 1.0, 2.0, 3.0, and 4.0, all of those /24s. And then we also have a 50.0.1.0 and a 50.0.2.0. So router 4 is what we're going to use as one of the vital parts of advertising networks into BGP. We're going to advertise its loopback 0.4 interface into BGP, and then we're going to see what the default action is without multipath configured and load balancing configured. Then we're going to enable multipath and enable load balancing on a per packet interface, per packet basis, and then we're going to see what the effects are when we do that. We're going to try to see what the reachability is to all these networks. So this is a very cool, exciting lab that we have for you. We are running internal BGP inside of Autonomous System 200. As you can see, router 4 has an RR next to this. This stands for route reflector. So router 4 is the route reflector. It is connected to router 2 and also router 3. If you're not familiar with BGP route reflectors, I have a video that explains that in detail. But a very high level explanation is that route reflectors allows us to bypass the BGP best practice, or IBGP best practice, where we must have a full mesh of internal BGP neighbors. Router 2 and Router 3 do not form a BGP relationship. They both peer to Router 4. So Router 4 has reachability to all IBGP routers, and so that's why it's going to be our route reflector. So it's going to receive routes from Router 2 and then reflect those routes to Router 3 and vice versa. So I just wanted to give you our current network topology. I wanted to give you an overview and a summary of what's going on. I think that just about does it. And also we do have a external BGP or eBGP relationship between Router 1 and Router 2 and also Router 1 to Router 3. So in this scenario, we're going to be using multipath across two links. We have two links, in this case to Autonomous System 200. We'll just call it our ISP, our Internet Service Provider. And what we're going to see is that multipath will allow us to do is to load balance across both interfaces, where in a normal setting only one of the interfaces or circuits would be used as the primary. And I'm going to show you that in detail. So after we configure multipath, we should see traffic start to use both of the interfaces out to our Internet Service Provider, whereas in a normal BGP configuration, only one of these connections is going to be considered the BGP best path. So let's go ahead and go on to Router 4. And what we're going to do is the command set interfaces loopback 0.4 family inet address. We'll give it our IP address. We get a statement saying that it is not found. This is typical if you're doing logical systems. You're trying to put on a loopback. In this case, this is what I've found on this router. So what we'll do is we'll just do this from the physical router itself. We were under the logical system we were logged into, as we can see by the R4. But now we're back to the main router. We'll just do the command set logical system R4 interfaces loopback 0 unit 4 family inet address 4.4.4.4/24, and we're just going to go ahead and add all of our networks. I just wanted to show you this. This is going to be very important to this lab, so that's why I did not pre-configure this. We also have 200.0.0.1 .4/24 1.4 2.4 3.4 and our last network is 4.4. Let's go ahead and commit that. Then let's log back in to our logical system. We do this with the command set CLI logical system and then our logical system name, which is R4. Next thing we're going to do is create a simple routing policy. We'll do the command edit policy options policy statement. We'll just call this loop. Then we're going to do the command set from our set term 1 from interface loopback 0.4. So we're going to match loopback 0.4, and we are then going to accept. The last thing we're going to do on router 4, we're going to do the command set protocols. Actually, let's do this. I'm going to show you our BGP configuration on R4. If I do the command edit protocols BGP, Do show. We see that we have a group IBGP, our autonomous systems 200, and we are peering with router 3 and router 2. We have the cluster statement. This is defining the route reflector as the local router, in this case router 4. And we'll do the command set group IBGP export, and then we're going to export our routing policy that we just created, which was loop. We're also going to go to router 1. And let's do this. Do the command set logical systems R1 loopback 0.1 family, set logical systems R1 interfaces loopback 0.1 family inet address 1.1.1.1/24 and 11.11.11.11/24. Let's commit that. Let's go ahead and log back in. Set CLI logical system R1. Then we're going to create a routing policy, edit policy options, policy statement, loop. We'll do the command set from interface loopback 0.1. Let's do this. We'll do delete from interface loopback 0.1. It's always good to have your terms set up just in case you want to add more stuff under your routing policy. We'll do the command set term 1 from interface loopback 0.1 and then set term 1 then accept. So we are, with the from statement, we're matching our interface loopback 0.1 and then we're going to accept it. We'll go to the top of the configuration. We'll go under edit protocols BGP. We'll do a show command to show you we have an external BGP group, our eBGP. We're peering to router 2 and 3. We're just going to export our routing policy that we just created. We'll do the command set group eBGP export and then our routing policy that we just created, which is called loop. Okay, so that should be good on router 1. If I do, before we go ahead and configure multipath on R1, let's take a look at the default traffic flow. Let's do the command show route protocol BGP terse, and we are seeing via BGP that we're learning all the routes off of router 4, all the networks. The next hop appears to be the same for all of the networks. So we're seeing 13.3. This is obviously our connection to router 3 if we look at our network diagram. Router 1 seeing the next hop as router 3 to reach all of the networks off of router 4 right now. Let's go back to router 1. This is more evident if I do the command show route receive protocol BGP 13.13.13.3. All of these networks have been added into our routing table and are the best. That's known via the asterisk. If I do a show route receive protocol BGP on our connection to router 2, those networks are being advertised to us as well, but they are not being added into the routing table as being the best next hop. One more command I can do is a show route. Let's just do on the 4 network 4.4.4.0/24 detail. Currently we are seeing just one next hop. Whereas after we enable multi-hop, we will show, or this will show up as being 2. Let's go ahead and do some traces. We'll do trace to the 4 network sources from our 1 network. It's going through 13.3 is the next hop, which is router 3. Let's trace route to the 200 network. Taking the same path, the 1 network is the 2 network, the 3 network. So what we're seeing is all the traffic right now is going through router 3 to get to router 4. If we do a show BGP summary on router 1, we're going to see another really good piece of information is that on our peer connection to router 3, we're seeing the state, a 7 shown, active 7. I'm sorry, the number of active routes is 7, received, accepted, also 7. And this is from router 3. However, when we look at the connection that we have from router 2, we see the active amount of routes is 0, but we are receiving 7 and have accepted 7. So I just wanted to show you this default behavior before we enable multipath. And then the last thing we're going to do is per packet load balancing. But before we enable multipath, I wanted to show you this information, the default behavior of BGP in a multipath environment. I'm sorry, the default behavior of BGP before we switch over to a multipath configuration. So now that I've shown you all that, let's go ahead and show you how to change this default behavior on R1. We're just going to go back under Edit, Protocols, BGP. We're going to do the command set group eBGP. If I do a space question mark, you can see that I have an option for multipath. And this explanation for this is to allow load sharing among multiple BGP paths. So that's exactly what we want to do. If we look at our network diagram, we have 2 connections out to our ISP, one through router 2, one through router 3, in Autonomous System 200. Right now we're just utilizing router 3 as the active next hop. We want to change this behavior on R1 so that we are able to utilize both of these connections at the same time. So we're under router 1, we're under our BGP configuration. We're going to do the command set group eBGP, and this is the group that we have set up that has our neighbor connections to Autonomous System 200. Do the command set group eBGP multipath, hit enter. We'll go ahead and commit this, and then we're going to do some show commands, some traces, and see if any of the traffic flow has changed. Our first command we'll do is show route protocol BGP terse. Okay, so now what we see is if I do a show route on 4.4.4.0/24, alright, let's just do this. Show route received protocol BGP on 12.12.12.2. We see that we have received all of these routes, but none of these have still are showing up as having the active path, and that's through router 2. Let's do another command. Let's do show route on 44.44.44.0/24. Let's do detail. And what we can see now is that even though when we do the show route receive protocol BGP, when we did that, we did not see that as being the active path through the 44 network. But when we do a show route on the 44 network detail, the next hop, we are now seeing two valid next hops. And the 12 network is the one that we are selecting. If we do a trace to the 12 network, if we do a trace to the 44 network, source it from our 1 network, we can see that the path has changed. Before, when we did the trace, let's see, I don't have that trace for the 44 network. Let's see if I can put one on, see if I can get one that has changed. Let's see. Let's go with the 200.0.4 network. Let's try that one. Let's go ahead and try to trace route to the 200.0.4 network. 200.0.4.4. Source that from 1.1.1.1. And the path is going through router 2. Whereas before, when we did the trace to the 200, looks like our trace before, well, we don't have 1 to the 4. That's great. Let's see. Well, what I wanted to show you is that afterwards, after we enabled multipath, we can now see that these routes are now, some of the routes are coming in and randomly being chosen to go through the connection to router 2. If we do a trace route to the 4 network, source it from the 1 network, that's going through router 3. So is the 200.0.0 network. The 1 network is going through router 3, the 2 network through router 3, and let's see, 4 network is through router 2, the 3 network is through router 3. And that's exactly what we see if we do a show route protocol BGP terse. The 4 network has the next hop of 13.3, whereas the 44 network has the next hop of 12.2. However, if I do a show route received protocol BGP on 13.13.13.3, it shows all of these networks coming up as active. And when I do the 12.12.12.2, we don't see any of them. They're being received, but not being selected as the best. But when I do a show route on the 44 network, like I'm about to do, what we saw is that we have 2 valid next hops, where the 12 network, or the connection through router 2, is the one that's being selected. We also see, when we do the show route detail, the information that says accepted multipath. So this is evidence that what we have done on router 1 is enabled multipath on the connections between our external BGP peers, router 2 and router 3. We are seeing the 44 network that's originating from router 4 is taking the path router 1, router 2 to router 4. also for the 200.0.4.0, that connection as well is going router 1 to router 2 to router 4, whereas all the other networks are going router 1, router 3 to router 4. So it's pretty random, the selection that occurs. Let's go ahead on router 4, and we're going to add the 50 networks in. We'll add 50.0.1.0/24 and then a 2.0 and see what happens in the selection process, the multipath. We'll do set interfaces loopback 0.4 family inet address 50.0. Let's see, what was that? 1.0. 50.0.1.4/24. And let's go ahead and commit that. We go to router 1 and do a show route protocol BGP terse. We are now learning the 50.0.1.0 network, and it appears as though the next hop is router 3. If we do a show route 50.0.1.0/24 detail, we're seeing the next hop. We're seeing two valid next hops, and the one that's being selected is the connection to router 3. We can trace 50.0.1.4 sources from 1.1.1.1, and we're seeing the path taken through router 3. Let's go ahead and see if we add another network. Let's just say 50.0.2.4. Let's see what happens when we do that. We should see the multipath take place. If I do a show route protocol BGP terse, now we're learning the 2 network, but it appears as though it's still going through router 3. If we do show route 50.0.2.0 detail, we're seeing the path through router 3 being selected. Let's do this. We'll just create multiple connections off the loopback 0.4 on router 4. Save. Actually, you know what no, that's correct. Let's do that. Let's just make a lot of networks, and then we should see out of these networks, at least a few of them should take the path through router 2. So with this push, we are pushing the 3 network, the 3, 4, 5, 6, 7, and 8. When we did that commit, all those networks should be learned through router 1. Our router 1 should be learning all those networks. Now if I do a show route protocol BGP terse, we can see all those networks now being added. And it appears as though if we look at 50.0.7.0, that one is now going through router 2. 8.0 looks like it's going through router 3. 50.0.6.0 going through router 3. 5.0 router 3. Same with 4.0 and 3.0. If I do a show route on the 50.0.7.0/24 detail, the next hop is 12, the 12 network. Let's go ahead and trace. We'll do a trace 50.0.7.4, sources from 1.1.1.1, and that is our path through router 2. Whereas the 8th network we saw going through router 3, which is evident through the 13 network. 6 is going through router 3 as well. 5 is going through router 3, and so on and so forth. So it's random. I just added a bunch of networks on router 4. We had to actually add 50.0.3.0 all the way up to 8.0, and when we added those networks, only one of those selected router 2 as the best path from router 1's perspective. And you want to know, one of the funny things is that when I practice doing this lab, of course, it only takes me 2 networks to show, 50.0.1.0 went through router 3, and then 50.0.2.0 went through router 2. But obviously, when it's time to record the video, that, of course, did not happen. So I apologize for having to add all those other networks. Sometimes that's just the way that the protocols work. In this case, multipath. So the last thing I want to show you is load balancing. We're going to do per packet load balancing. And what I mean by this is, on R1, if we trace route, let's just clear the screen. We do a trace route to 44, 44, 44, 44, source it from 1.1.1.1. Every time we trace, you can see that the next hop is router 2, evident by the 12.2. What we can do is we can enable per packet load balancing, and what this is going to do for this network is every packet that is sent across, it's going to change the next hop from router 2 to router 3 to router 2 to router 3, and back and forth. On router 1, if I do the command show route forwarding table and then matching, and then match the 44 network, if I do 44.44.44.0/24, we can see the next hop. We're only seeing one right now, which is router 2. And that's for our destination 44 network. And it gives us our interface. So a lot of good information with the show route forwarding table matching, and then our specific prefix that we wanted to see the information. Let's go ahead and enable per packet load balancing and see if that changes anything. We do the command set routing options. I'm sorry, let's do this first. First thing we want to do is create a simple routing policy. We'll do that with the set policy options policy statement. We'll just call it load balance. I'm sorry, instead of set, let's go ahead and go under edit. We'll do edit, policy options, policy statement, and then load balance. And then we're going to do the command set, and all we need is an action in this case. We'll do set then space question mark. We have the option for load balance, and this is a type of load balancing in the forwarding table. So we'll do the command set then load balance space question mark, and you can see that our only option that we have right now is per packet. So we'll do that. We'll do per packet load balancing. We'll go ahead and commit that. We'll save that routing policy. The last thing we want to do is go ahead and export this routing policy to our forwarding table. We'll do that by doing the command set routing options forwarding table export, and then we're going to export the routing policy that we just created, which is called load balance. We'll go ahead and commit that on R1. if we go ahead and do the command to show route forwarding table matching 44.44.44.0/24, now we can see that the next hop, instead of just having a single next hop, we have two next hops. Let's trace to the 44 network. We see that we're using the 13 as the next hop. Now we're using 12. We're using 12, 13, 12, 13, 12, 13, 12. So pretty cool. What we're showing you with all these traces is that the next hop is changing randomly. We see the 13, then we're seeing the 12 being taken. So router 3, router 2, then router 2, router 2, router 2, router 2, router 3, router 2, router 2, router 3, and so what we have done, if we go back to our network topology, by enabling load balancing per packet on the forwarding table, we're seeing that to reach the 44 network, every time we trace, it's taking a different path. Let's just do a trace route on another network. Let's say 50.0.5.4, source it from the 1 network. It's going to 12 network, it's going to the 13, the 12, the 13, the 12. We do show forwarding table. Or show route forwarding table matching 50.0.5.0/24. The next hop, which was 1 before, is now showing up as 2. And what I also wanted to show you, if I do a show BGP summary, before, when I did a show BGP summary, we saw from our peer, which was router 3, the active amount of routes was 7. Now that we've added 8 more routes from router 4 into BGP, we're seeing the active amount of routes is 15. Before we enabled multipath on router 2, we saw that the active amount of routes was 0. So the difference, what we're seeing now after we enabled multipath, is that the active amount of routes is the same for both of the paths. So before it was 7 and 0, and now it's showing 15 and 15. So pretty cool feature, the multipath feature and the load balancing per packet. Just to sum things up, we went through and we showed you how to perform multipath on router 1. We did a lot of show commands before and afterwards to verify that and what multipath enabling it would do and change. Before, we saw all of our routes coming through router 3 from router 1's perspective to get to all the routes off of router 4 and our traces and our show routes. After we enabled multipath, we saw that router 2 was then being considered the best path and active for some of the routes. It took us a while, but that's just the nature of the beast. And that's the way multipath works. It's random. And then the last thing that we did was we enabled per packet load balancing on the forwarding table on router 1. We created a simple routing policy. We go back to router 1 and show you this. Let's show you exactly what we did in this lab. First thing we did under BGP, under group E BGP, we enabled multipath. Then the second thing we did was we created a routing policy called load balance, in which we matched, not matched, but we set our action to load balance on a per packet basis. After that, we went under the routing options under the forwarding table and exported our simple routing policy that we created, which was called load balance. After we did that, we looked at our forwarding table for our specific prefixes, and we saw that instead of just having one valid active next hop, we were seeing two. And when we did our trace to the specific prefix, in this case the 44, we saw that some of the traffic would go through the router 2, then some would go through router 3, and so on. So I want to thank you for watching, and I hope to see you in the next video.